Hi everyone, we're going to find the area of the region that lies inside the first curve and outside the second curve. Basically, these are both circles. The second curve is this one. It's the easy circle with a radius of 1. So this one is r equals 1. The first curve is a circle as well, but it is shifted to the right by 2 units. All right, so basically with that being said, let's find our points of intersection here and here. So to do that, you're going to set 2 cosine of theta equals 1 and solve for theta. So you get cosine of theta equals 1/2. So that means our angles are going to be pi divided by 3 or 5 pi divided by 3. So this point right here is actually 1 comma pi divided by 3. And this point here is with 5 pi divided by 3. We don't need that really. So basically, let's read and see what we have. Find the area that lies inside the first curve. So this is the first curve, this green one. So inside of this, but outside of our simple one. So it's going to be this area here. Now, if I just go to 0 to pi divided by 3, then all I have to do is multiply it by 2 to also get the area of this one, 0 to 5 pi over 3. So this is the whole area we need, but when we integrate, we're going to make our upper and lower limits 0 to pi divided by 3, and then we're just going to multiply it by 2 to get this yellow area as well, because we need the whole thing. All right, so let's do that, and we're going to integrate using this formula. So the way you do it, you're going to find the area equals 2, because we're going to multiply this by 2, times the integral from 0 to pi divided by 3. And using this formula, this is going to be 1/2. And we're taking the area of the first curve minus the area of the second curve. All right, d theta. Now this just equals 1. So we're going to get this equals the integral from 0 to pi divided by 3 of, let's square this out, 4 cosine squared of theta minus 1 d theta. Now for integration purposes, I'm going to use our identity. Let's go ahead and do this. Pi divided by 3. Let's pull out the 4 right here for now. And I'm going to use this identity 1/2 times 1 plus cosine of 2 theta minus 1 d theta. Okay, so basically what happens is you're going to get 4 times 1/2 is 2. Right? So this is going to be, I'm going to simplify this. So this is going to end up being 2 plus 2 cosine of 2 theta, and then you still have this minus 1. So that's going to leave us with the integral from 0 to pi divided by 3 of 1, because you 2 minus 1 is 1, plus 2 cosine of 2 theta d theta. Now we can integrate this, so let's do that. We're going to get this equals theta plus sine of 2 theta, and we're evaluating it from 0 to pi divided by 3. At 0, it's just going to go away, so we only have to use this upper limit. We're going to get pi divided by 3 plus sine of 2 pi divided by 3, and the rest is just going to be minus 0 minus 0. or plus 0 there. All right. So this is going to end up being pi divided by 3 plus square root of 3 divided by 2. And this is your area of that certain region that's inside the first curve and outside the second curve. Thank you. Have a nice day. Bye-bye.